Have you ever played War Thunder? No, you haven't. Well, very good for you. But have you ever thought to yourself, okay, how do I make such a large level, especially for flight sim games? That too for mobile devices, because like every War Thunder player, I like to torture myself. No, well, I have. Most flight sim games that I could find for mobile devices were quite limited when it comes to level size. And I decided to take on the gargantuan task of trying to fix it, trying to make a huge level for a flight sim game, that too for mobile devices. That means I have to make it optimized enough to ensure that it runs properly. Yeah, God help my soul. I'm new to this YouTube thing, so I don't know how to start. So just, I guess, cue in the intro. Making a large level is nearly impossible due to the floating point limit. Now, what's that, you may ask? A float value is basically something that your computer uses to represent numbers, more specifically numbers with those decimal points. Now, each float value is a 4-byte value. Translating that into English, it basically means you can describe up till 7 decimal digits. Now, 7 decimal digits might seem like a lot, that is around 9,999,999. But considering that the vertices in each 3D model is just a few millimeters apart at times, you need at least 3 digits behind the decimal. That brings back the size to 9,999.999, and that basically comes at around 10,000 meters in one direction. You take that for the positive and the negative directions, you get a total level size that has around 20,000 meters width. Now, that limits our level size to around 20 kilometers by 20 kilometers, and if you're taking a fighter jet that flies at Mach Jesus, you're gonna cross that size in roughly 30 seconds. Many games try to reduce this effect by making the level small and making the jet slower, but that looks like shit. The only way to fix this is to actually make the level big. Now, many large open world games fix this issue by the floating origin point system. That's basically when the player moves far away from the origin and the player and the level itself is shifted back to the origin. This effect is barely noticeable for the player themselves, but this allows them to maintain the precision, especially for 3D models and game physics. Now, this works great for single player games. You just have to handle one player. But what about multiplayer games? Again, as I stated in the beginning of this video, I love torturing myself, so I wanted to make this a multiplayer game. How do you fix the floating point issue? So, the very simple answer to that is basically you shift the level for each player. Now, to make it a bit easier, and I know this might sound quite ironic, but I decided to use Unity dots, mainly because I could split the visuals and the physics. The visuals will be done by game object logic, and the physics, the collisions, will be handled by Unity dots because it's way more efficient and also way more optimized. And at the same time, the advantage of splitting physics and rendering in two separate places is that you can render the level for each client separately, and the physics will only happen if they are in the same local area. How do I define the same local area? I take a chunk that is of a set size, for my intents and purposes, 7 kilometers by 7 kilometers. And then when you take these chunks and make a 27 by 27 grid, all of a sudden your terrain is as big as 189 by 189 kilometers across, or the size of KSI's forehead. Now, after long hours of research, I found a tutorial by Brackies on how to make terrain like meshes. So let's try that. So let me check out my project and open up the tutorial.
The next step is to define the triangles that make up our grid.
That's not how it's supposed to be. I mean, it's not supposed to be vertical, but alright, I mean, I'll take that. It's a grid.
To 0, we'll create a float called y. We'll set it equal to math.per_the_noise. We'll input our x
noise,
and
yeah,
z.
okay.
And now, when we run it, we can see that we're creating this really cool uneven terrain-like surface.
What? Huh? How? After bashing my head against the wall and trying to fix the code, I finally figured it out. I finally made a grid. Now you can take it up a notch and completely procedurally generate the terrain like Minecraft. But since I'm diagnosed with skill issue, I think I have to use height maps. Height maps are black and white images that represent the height of a terrain. The white pixels on a height map represent higher points, and the black pixels represent the lower points. and everything that is gray lies in between. I wipe coded a Python script that uses OpenTopography's API key to generate these height maps. This script generates 9 height maps. These 9 height maps are supposed to form a 3 by 3 grid around a particular coordinate, and each height map represents 189 by 189 kilometers. I only want my level to be around 150 by 150 kilometers. The rest are just going to be in the background to make sure that the level feels full. After saving the height maps, I import them into Unity, and then I convert them into R16 images. Instead of having RGB in each image, I just let it have the red channel and with a 16-bit depth. This allows me to store large numbers inside the height map and more precision, which will allow me to show a greater amount of depth in the terrain. After that comes the hellish part, that is actually generating the terrain with LOD. Basic idea behind this being that only the terrain that is near to the player is rendered at full capacity, and the terrain that is farther away are rendered in bigger chunks with less number of vertices. Now this greatly improves our polygon count, but at the same time we also reduce the number of objects we spawn inside the level. Again, a level that is 189 by 189 kilometers, which is split into 7 by 7 kilometer chunks, still makes a grid of 27 by 27 objects, and that makes up around 729 objects, which is really inefficient. So here I have my terrain generation script. As you can see, we have all the variables that are necessary for generating the chunks. At the start you can see the s-byte variables x, y and z. This basically looks at which chunk in the x, y and z directions the player is in, and this will allow us to render the terrain with that offset to ensure that the player is always near the origin. Then we have the other variables that are the x and z resolutions, the height map that is used, and the tile size. This basically uses the same script, but instead of the Perlin noise, we are using the height maps value. And at first we are going to be taking all the height data in this float 2D array, and then we will use that to generate the chunks. As you can see over here, I have made two lists. One is active chunks and the other is updated chunk list. The active chunks basically keeps a note of which chunks are active, and the updated chunk list keeps a note of which chunks are to be updated. Over here in the code, you can see over here we have two functions, one of which is going to generate the tile and the other one that is going to do the math behind it. And then we have the update terrain function. This basically takes the x and z s-byte variables, and then it checks which tiles exist. The ones that do not exist, it generates it. Here we can see that the script looks at which tiles are generated, and after that it checks which LODs are to be generated. First it looks at the highest level of detail, it generates the chunks near the player, then it takes the corresponding lower LOD chunk and then omits that chunk, and then generates all the other LODs. It does this 3 times over to generate 3 level of detail chunks, and as you can see, this greatly cuts down the number of objects that are in the level and optimizes our result. Here you can see I'm changing the x and z variables, and the terrain moves accordingly, and also the level of detail chunks are generated accordingly. The update terrain function also makes it so that only the chunks that are supposed to be newly generated are generated. The ones that already exist in the scene are not deleted, and the rest that are supposed to not exist are deleted, which also increases processing performance. I did the same for the other 8 height maps. Now these are out of bound terrain tiles, and also the player is never going to be there. Instead of generating small tiles, I decided to render the terrain as a whole, but instead of tiling it and chunking it for having 64 vertices by 64 vertices, I just generated the entire terrain with the resolution of 256 vertices by 256 vertices. And this gives us an expansive terrain. It looks plain, it looks white. Let's add in some color. Yeah, please don't ask how many sleepless nights I had to endure to make the shader. I'm still working on it, and yeah, it certainly isn't the best right now. I'm definitely going to make it look better. Now, that's it for today. I hope you guys enjoyed my content. This is my first time posting on YouTube, and I am really passionate about this project. I wish to make this a flight sim game for mobile, especially one with a huge terrain. That is something unheard of for mobile devices. It took me a lot of effort to get till this level of progress, and I wish to work on this more. So if you are supportive of this, please do like, share, and subscribe. I don't really have an outro for this YouTube channel of mine. So until next time.